Okay, here we go. Look at this diagram. Is this endothermic or exothermic? Endothermic, and we know this because products are higher than the reactants. That's right. Okay, so let's go through and label these, and then we will do the numerical values. What is A? Yes, it's the height of this peak, so it's the activation energy. What is B? Very good. It's the delta H of the reactants, or energy of the reactants. What is C?
Overall, delta H of the reaction.
Very good, Samantha. Overall delta H of the reaction. The difference between products and reactants is the overall heat of reaction. Yes? B is the energy or enthalpy of the reactants. The height of the reactants. This is delta H of the reaction. We don't know this yet, okay? That's for another time. Huh? Nope. This, the height of the products, this is the delta H of the products. Very good. Now let's do numerical values. What is the value of the activation energy?
240. 160.
Start here, go here. It is 160. Spivey, you have a question? I'm sorry. The C was the enthalpy of the reaction, the overall. Yeah, delta H of the reaction. Enthalpy and delta H are the same thing.
Then B is of reactants?
Reactants. And E is products.
Okay.
Yeah,
For C, I put delta H RXN.
that's right. Delta H RXN, that works. Yes.
Are going to be N with a S, reactants with a S?
Yes. That's what B is. So what's the value of the activation energy? 160. 80 minus 240, 160. What is the value of the enthalpy of the reactants? Okay, good. What is the value of C? The enthalpy of the reaction overall is 80. What is the value of E? 160. So you could get C by taking E products minus reactants. 160 minus 80 is 80. Is there anything about this one that you have a question about?
Did you say that B was 80?
Yes. Anything else? No, that's something else. All right, turn it over. Endothermic or exothermic? Very good. Products are lower in energy. They've released all that energy. By the way, what does your beaker or test tube feel like when it releases energy?
Light.
Hot.
Oh.
Yeah. Well, yeah, lighter, but it's going to feel hot. If it's endothermic, taking in energy, it's going to feel cold. Okay. What's A? Activation energy. Good. What is B?
Reactants? The energy of the overall.
Yeah, that's
Yes.
what I thought.
Delta H of the reaction. This is the overall change in energy. It didn't go all the way down to the bottom. If it had, you would have been right about reactants. This is the change between these two. Does everybody see that? Delta H RXN. That's right.
Wait, so A is the activation energy?
Yes.
Why wouldn't it be the products? I mean, the reactant?
It's not on here. If we wanted to do reactants, I would have had a line all the way down. Okay?
I thought C was activation.
That's the thing we haven't learned yet.
No, that's the thing you haven't learned. No, activation energy is the distance from the reactants to the peak. Not the products in the peak, but the reactants in the peak. That's a good question. Lastly, D.
Energy of product?
Yes, you all said it correctly. Energy of products, delta H of the products, enthalpy of the products. That's right. Okay, so what is the numerical value of activation energy? 80. If you don't know why it's 80, please ask.
You just subtract 160.
Bingo, yes. 240 minus 160. What is the overall enthalpy of the reaction, delta H RXN? 80. 160 to 80 is 80. What is the enthalpy of the products? 80. Is there anything on this diagram you want to ask about?
Is it always, is A, B, and C always going to be the same? Oh, wait, never mind.
No, they're going to change. They're going to change. Don't memorize A is always this, B is always that. No, memorize their location, where they are. You're going to get a lot of practice today.